Now we get to dive into something truly exciting. Why? Because fire is involved. We all love fire, just admit it. There's no shame in that, it's fine. You've got copper plumbing in your house maybe, you've got leaks to fix, you've got changes you want to make to your existing plumbing, whatever it is, you're probably going to have to deal with copper at one time or another. Copper comes in two different sizes. Commonly in residential plumbing, it comes in a 1/2 inch and a 3/4 inch. It also comes in two different types. And what you're looking for is just the standard residential grade is fine. The thicker walled stuff is also fine if you want to spend the extra money, but it's only required by codes in certain commercial applications. The thing is, at the local big box store, they have them sitting right next to each other. And if you don't pay close attention, you'll pay approximately twice as much for the length of copper you grab. It's the same length. It's just the thicker wall that you really don't need in a residential application. So, 1/2 inch to 3/4. Now, depending on what you've decided to do, your soldering experience might be dramatically different than what I represent here. So please bear with me because we're doing this on a project board. It's real simple, it's real easy. There's nothing in the way. There's no concerns about what the fire's going to do beyond the solder. And those are the sort of things you definitely have to deal with. So I'd highly recommend you take a minute to watch the safety video and then come back prepared. Okay, we'll start with the torch for just a moment. This particular torch I've had for a few years, very good, very reliable. It's a push button start. It also has a button where once I've pushed it, if I push this top button, it will stay on without me holding the trigger. Like so. And you just push the trigger again to release the set, and it's good to go. This knob back here controls the size of your flame. Watch. Ooh. I keep it pretty much wide open most of the time. Well, not quite wide open, but maybe 70%. That section, I'm going to turn it on again, give the camera a chance to grab it. But that light blue section, right at the tip of that light blue section is where you're going to generate the most heat with MAP gas. On that note, this is MAP gas, not propane, and it burns dramatically hotter than propane. So although it heats up the fittings quicker, it also creates more heat in the surrounding area, and it will take that copper a little bit longer to cool down without some help from a wet rag or something like that. So if you're using MAP gas, great. But take your time and be patient and be ready for it quick because it heats up fast. Now, watch for the tip of the light blue part. That's where you're trying to get it on the fitting. That's where you're trying to get it on the fitting. We'll show it in more detail when we solder. The other thing we use for solder on fittings is flux. It's called flux. It's a chemical that draws the solder in around the joint. It also prepares the copper to accept the solder. I use a water-soluble flux. Some plumbers prefer the old style that's not water-soluble, but I definitely want the water-soluble because of its cleanup potential. It gets everywhere. It can make a big mess, so having it water-soluble comes in very handy. Okay, some other components of a copper system. Obviously, we talked about the sizes of the pipes. Comes in 8-foot, 10-foot lengths. You can get it longer. You can get it in rolls, but it's difficult to get flat and really get it to fit in the fittings well. Copper comes with a wide array of fittings, everything from adapting from a 1/2 inch to a 3/4 inch with a fitting like that to what would be called the standard L. They also make them called the street L that fits over the pipe, but on the downturn it's narrower so it fits inside a fitting. That keeps you from having to use really short sections of copper tubing. But you can get just a shocking variety of fittings for these to allow it to adapt to water heaters, to faucets, to main entry lines, pretty much any purpose you can imagine. Copper's reliable. It's been around for a long time. Of course, it's subject to corrosion, but there isn't a lot of oxygen passing through the pipe, just what's in the water. So you have a good really a good solid lifespan from this. The biggest drawback is its limitations in the small areas it can fit. Sometimes it's hard for it to do a turnaround or something of that nature. And the fact that you have to work with a torch and flux and that sort of thing when you're actually doing the soldering. Now, to solder effectively, you need a couple of things. The main thing you need is a clean, burr-free pipe. Now, a burr-free pipe, the burr is that little edge that's left after it's been cut. So once it's been cut, you need to remove that burr, and that's done. You know what? Why don't I show you how to cut the pipe first? Isn't that a great idea? Yeah, let's start with that. Here's a section of 1/2-inch pipe. Assuming you've made the mark for the measurement you want, there are a number of different types of pipe cutters on the market. This one is becoming very popular, and I'll show you why. It's very easy. It's got a spring-loaded blade, and all you have to do is snap it on the pipe at the mark you made and rotate it. Now, as I rotate it, I'm spinning the pipe as well, and that blade, through spring tension, is working its way further and further down until the pipe is cut. Now, it will leave a small burr sometimes, depends on the cutting blade, but that burr needs to be removed. Another method of cutting pipe, we'll talk about removing the burrs in a minute, is this type of cutter right here. Let me set this pipe down. This type of cutter is standard. It's been around for years. It's a great tubing cutter. It'll go rather large, and it has this built-in what's called a reamer that removes the burr from the inside edge of the pipe simply by twisting it inside of the pipe. It cleans off that inside edge. So that's kind of convenient that it's right there on the tool. Those come in handy. Their limitations are how much clearance they need around the pipe in order to spin all the way around it, because they do have to spin all the way around it repeatedly, and then you adjust it and spin it again and adjust it and spin it again. Every couple of spins you'll want to tighten the handle until the pipe comes off. My favorite method is this device. It's kind of new to the market, although I've seen a couple of models in the past couple of months, so other manufacturers are catching up. It is a ratcheting type cutting device where as you move the handle, it continues to move the cutter, even though the handle only moves a couple of inches. This allows you to get into some really tight areas and still make a good effective cut without having to reach all the way in there, areas that this tool could never possibly reach because it needs too much room around it. Now, the ratcheting effect is great. It's a pretty fast cutter. It also has spring tension on it. So basically the way it cuts is you loosen it, get it on the pipe where you need it. I'll get it set. And it needs to go right between the rollers with a cutting blade on the other side. Now, once it's in place, I'm going to tighten this. Its directions said 4 half spins, which is 2 full spins. I'm a math. Look at me, math. Basically, you're just going to ratchet this around the pipe. Its spring tensioner is pushing the blade farther and farther in until it cuts it clean. And there it is. And you're ready to remove the burrs, clean it, and use it. Now, once your pipe has been cut, we talked about deburring. There are a couple of ways to do that. You saw the deburring tool that was on the back of the tubing cutter that pops out of the back of there. That's great if you've got one of those. This kind is also very popular. It's called a reamer. It reams the burrs off of the pipe. The one side is concave with 3 blades. It is designed to remove burrs from the outside of the pipe. Just a couple of spins, and the outside of the pipe will be clean and ready. The inside of the pipe, you flip the tool around, move it around the other way a little bit. Doesn't take a lot of force, and now the inside of the pipe has been deburred as well. Now at this point, you need to clean any oxidation off of the pipe. That also needs to happen before it can be soldered. There's a couple ways to do that. This is probably one of the most popular ways. This tool right here is basically a pipe cleaner, is what it's designed to do. These ends, you'll see a 3/4 inch end and a 1/2 inch end. Those are designed to clean the inside of the fittings because they have to be cleaned before being soldered also. And obviously these circles with the wire brush filaments in it are designed to clean the outside of the pipe. So you basically just run it around the pipe a couple of times and make sure it's nice and clean. You can see the difference there. That's a clean pipe ready to accept solder. Now, since this assembly has been mocked up, none of it has been cleaned, so I'm just quickly going to clean the fittings. The other way to clean them is to use a sanding cloth or emery cloth. It's designed just for this. It's cut in a good size. You just tear off a short strip and use it in a circular motion. You're basically sanding off the oxidation. Keep sanding. You're trying to get the oxidation off to make sure that it's ready for solder. It won't accept the solder or bond to the other copper component properly unless it's been properly cleaned. So it should look about like that, like the others. The inside of this one has been cleaned to accept the copper that's going to go inside there. We've got one fitting left to clean. Clean the inside of it quickly, and then we'll get to the next step. Oh, I'm sorry, we have to clean the top of this pipe as well over here. We'll use the paper for that. Just using the towel to wipe off the excess debris from the sanding. Make sure it's ready. Now, the next thing you need to do is to apply flux. We talked about flux briefly for a minute earlier. I use a water-soluble flux. What it does is it draws the solder up into the joint and allows the solder to spread evenly throughout the inside of the joint. And it also chemically treats the copper, etches it, if you will, to help it accept the solder as well. So we're just going to apply it. I'm of the school of thought that too much is better than too little, so don't be afraid to overdo it. You definitely want it going out past where the fitting is going to be, excuse me. So we're going to spread it evenly around the inside edges of the fitting as well, so that we've got a good, thick, even coat all around. Now that fitting can be placed in place just like that. We've got our next section. What do I do with that little guy? There he is. Get him cleaned. He's cleaned already. We'll get him fluxed up. Slid in there. Now, if you are ever soldering an assembly with some twists and turns and different fittings in it, it's probably a really good idea to do as much of the soldering out of your project area as possible, and then just do your last solder joints to put it in place where it's got to go, mostly because a lot of times the constraints of the area can make it kind of a challenge. So feel free to drill a 1/2-inch hole into a 2x4 or something similar to what we've done here. There's a bunch of different ways to hold the copper while you're soldering it. I've been known to hold it with a pair of channel locks or slip joint pliers in the path of the flame, so that I don't get burned, obviously, but to make sure to hold it steady. This fitting here, as well as the L fitting, have unique properties in that we've got to essentially solder two places at once. When you're soldering, you're trying to heat up the fitting, not the pipe. The pipe will heat up on its own. So you're going to direct your flame at the fitting. I'm sorry, not the pipe. Another advantage of MAP gas over propane is because it does get hotter, it handles 3/4 inch copper much better than propane does. Propane takes a while to heat up, and when you're working with 3/4 inch, there's that much more material absorbing the heat, and it can make it take even that much longer before it's accepting of the solder. Okay, at this point, that guy is ready to solder, so I want to make sure I have everything I need. I need a roll of top quality lead-free solder. There's a bunch of different brands, but you're looking for the solder designed for copper soldering and plumbing soldering. There's some other types out there, and obviously an electrical type solder isn't really what you're looking for this case. So it is expensive, so be prepared. Maybe you only need a small section because you're just doing a small repair, so that might save you some money there. I unroll enough of it to manipulate it from a distance. It is fairly rigid. I give the end, the last couple inches, a little bit of a turn because I know I'm going to use an inch or so, maybe a little more per fitting. So once I've got my solder just like this, I'm ready to get to the soldering part. Now, in a case like this, obviously we're not going to hurt the board, but just for the sake of consistency, if nothing else, we're going to put the heat blanket in place. You might tuck a couple of these around the base of a joint like this if you were soldering it in place in the wall. You might hang one or two by their grommets around the perimeter of it to keep the heat from transferring to those surfaces as well. Now at this point, we're just going to move from joint to joint. Now what I want you to watch for is the first thing that will occur is that you'll see some color change in the copper, but then you're also going to see the flux begin to bubble and smoke and sizzle a little bit. That tells us we're getting close to the heat range with which it'll begin to accept solder. Now what you'll see me do is occasionally I'll tap it with the solder, and I'm watching to see what the solder does when it touches the pipe right at the joint. I'm waiting to see how quickly it melts it and if it begins sucking it in on the inside there. Okay, now before I get started with this, we always want to make sure we're wearing safety goggles. We're dealing with fire, the potential for spattering solder, anything could happen. And just by wearing these, we dramatically reduce the risks of injury. So take a minute to put on some decent safety goggles. I've got the fire extinguisher ready. I've even got a wet towel to wipe the surface afterwards, because as soon as the solder is in that joint and you feel confident that it did its job, you want to wipe that flux off so that it doesn't continue to erode the surface of the pipe on the outside, and in general it makes it look a little better. Now I got to be honest, I've been doing this for years. I still wish my solder joints were prettier, so I hope after some practice yours will be even prettier than mine. Let's see what we can do. We're going to start on the bottom here, and then we're going to work our way this direction. The reason why I started on the bottom is because I need that flux to suck that solder up before it all gets melted away, because the flux will eventually steam away, gas away, it'll burn away in the process of heating up. So if we get that solder in place first, then I can move kind of to this side. They'll both should be ready about the same time. If I start at the top and then go to the bottom, the heat might have removed too much of the flux and it won't want to suck the solder up in that joint. It's happened to me before. So little tricks, if I can help you, let's see if we can do it that way. Okay, we ready? Let's do it. You can see I've turned off the flame because it's hot enough. And I'm moving around the bottom of the joint, trying to get all the way around if I can. I'm going to heat it up a little more to make sure that the top is happening properly. I hope you can see the detail of this, but it's sucking it in that joint. Go all the way around. Don't worry about the parts that fall off because they're landing on our heat blanket, right? Now, without changing step, this next one is close enough that I don't want to waste any time. I want to keep the heat that I've already generated and use it to our advantage. So I'm going to do this first joint and then we'll move to the big one. There it goes. Make sure it This one is hot enough as well, even though it's 3/4. We've been putting so much other heat on it. Too much solder might not make the prettiest joint, but it sure does make sure you've got plenty of solder in the joint, so don't be afraid. Now, with your rag good and wet, so you don't burn yourself, just wipe that flux off there. You should be good to go. Okay, well that's cooling off. As you can see, my joints could be prettier, that's for sure. But should we put water pressure on this line, we could be pretty sure that it's going to hold water pressure just fine. Now, in my experience, the places you can expect to maybe find a pinhole leak when you turn the water back on, and you have to understand that happens to the very best of professional plumbers from time to time, so don't feel bad if it happens to you. That's what practice is for, and there's ways that it can be fixed. The chances of finding a pinhole leak are going to be in this bottom joint here, and up here where we've adapted from 1/2 inch to 3/4, in that area there you might find a leak as well. So once I turned the water pressure on and came back, those would be the two areas I'd really be looking at in high detail to make sure that we've got a good tight seal there. Okay, moving on. When you're dealing with a supply valve of some kind that's designed to be soldered in place, there is a slightly different approach you need to take, because there is some rubber washers or sometimes some seals or fittings in here that you want to be conscious of. Now, in the case of a gate valve such as this, where it just essentially moves a gate up and down inside to close off the water supply, it's not as subject to the heat damage, which is what makes it an ideal fitting for a cutoff valve like this. Now this is a cutoff valve you might use on a water heater if you had half-inch line going to your water heater. You might use it to turn off a section of the house or a hose spigot or something of that nature. The process is very, very similar. You're going to cut the pipe, ream the pipe as we discussed, inside and out. You're going to clean the pipe the same way we discussed. Apply the flux on both the clean surfaces here and the outside surface here. You're going to mate them together, and you're going to go ahead and heat up this area right where the pipe goes into the valve. And be patient, because it will take just a little while for it to get hot enough to accept the solder. So I'm going to go ahead, I wasn't going to, but I feel spunky, so I'm going to clean it real quick and ream it, and we'll get it soldered up. See if it gives me a hard time today. Okay, pipe is clean enough. Put the valve down here. I need some theme music. That's what I need. Okay, the inside of the valve gets cleaned with a brush. This one's designed to solder on both sides, so I would just go ahead and clean both sides even if I'm not going to solder the other side right away. Going to apply the flux. Now, as I mentioned before, you want the flux to extend past where the fitting covers, and I don't know if I did a good job of explaining why, but if your flux stops short of exiting the fitting, then there's no flux for the solder to ride in. It's got to ride in just on the copper pipe before it gets to the flux. I find failed solder joints like that a lot, so it really is something where a little too much flux isn't the end of the world compared to not enough. So don't be shy. Flux is cheap. Okay, we've got those solder joints. The other thing I did is I've looked very closely at this valve and made sure it's not a directional valve for some reason. If it has an arrow on it, you want to make sure your water flow goes in the direction of that arrow. Okay, I put the right side on there. Yeah, I did. Yay! Okay, I'm going to make sure our area is clear because solder is bound to drip. I'm going to peel out enough that I can maneuver it properly. Get a couple of inches pointed at the angle I want to be able to use it effectively. I'm going to turn it so it might be a little easier for the camera to see. We're going to get this soldered up. There it goes. Now, the other thing I didn't mention, I failed to mention, I'm sorry, was that when you are soldering a valve, such as this, you need to turn the valve all the way open. If it's closed, it encloses the heat and that steam, and that's just more pressure and heat that it's going to hold against those fittings and seals. So make sure the valve is turned all the way open before you solder it. Now at this point, I'm going to wipe it down, make sure it's clean with a wet rag, a really wet rag, to make sure I don't get burnt. Because it'll be hot. Actually, this fitting is warm to the touch, so that heat will definitely travel. And an object with as much brass in it as this valve will stay hot for a little while, even though I'm wiping it with a wet rag. So be patient, be careful, don't burn yourself. I burn myself every once in a while, it's not fun. Turn on your water after closing this valve and check for leaks, make sure it's okay. Now, if you find a leak, whether it's on the low side of here or whether it's on the back side of a valve, something of that nature, you can take a moment, reheat up the joint, and try and apply some additional solder. I've had some success with that, but make sure you pay close attention to it for leaks for the next little while you're interacting with the rest of the job. Worst case scenario, heat it up, remove it, clean the joint, clean the outside of the pipe, apply fresh plux your fresh flux, apply your fresh flux, get them set back together, and try to solder the joint again. Okay? Now the last thing we're going to tackle in regards to copper and repair is if you have a pinhole leak or something of that nature on a straight line. There's a couple of ways to handle this. One of the ways to handle it involves these. They're called shark bite fittings. I'm going to use a larger one just for kicks. The shark bite fitting is very, very simple. It's a mechanical fitting that once it's slid together will not come apart without a release, one of these release keys. It'll spin, but it seals great and it won't come apart. Now to get it to release, there's a small collar right there. You slide the tool onto the pipe, press the tool up against that collar, squeezing that collar in place, and then turn and spin until the shark bite comes back off. Now one thing about shark bites is they have to be on the pipe a certain distance before a seal can be assured by the company. So their procedure is to measure down, I think it's an inch or an inch and an eighth, something like that. Or you can use one of these. It just slides on the pipe. You make a mark, and then you make sure your shark bite goes down to that mark when you install it. This is an easy way. It works great. So now what we're going to do, slide the shark bite on, push it nice and hard, make sure it comes right up to the line. We know we've got a good seal. Shark bites are wonderful. They are kind of expensive. This one right here, I believe, is around $6, maybe a little more. So they're not inexpensive. But there are plenty of times where just trying to get in there to solder is not going to work. So they're wonderful. They're code approved. They can be hidden inside walls with no concerns. So they're a great product. So we could obviously cut out the bad section and reinstall a new small piece of copper with some shark bites. That's certainly one way to fix it. You'd be putting in a new piece with 2 shark bites. There are a couple of other ways to handle it though. The first way that I'm going to show, well no, let me show you the other way first. The other way is with a line like this that uses compression sleeves in it. Now it is designed to fit onto the pipe you already have, but it has to go in a certain distance. Basically, you're going to go to the base of the threads here and make a mark. Like that. And then while holding it still, go over here to the base of the threads and make a mark. And those are going to be the 2 areas where we cut. We'll use this cutter just for kicks. I'm going to make this cut, and then we'll cut the pipe at the other location. Now, once you've cut and removed this pipe that has your small leak in it, or maybe it's a burst area from a freeze, something of that nature, you're relying on the flexibility of the copper lines, which is limited, I'll be honest. But you need its reliability or its shiftability where it's at in the crawl space or wherever you're working with it to allow you to get these pieces in. That can be very challenging sometimes, but as you can see how it slides past it? Then you move it past the first one, slide it into place. Of course, I didn't put the nuts and the ferrules on, so I've got to take it back apart. I'm going to slide the nut on first, then the ferrule. This is called the ferrule. Basically how this works is as this tightens onto the fitting, it's going to compress this ferrule into the outside body of the copper, and it'll create a really solid, reliable seal. This is one of the more expensive ways to do this repair also. I believe these sleeves are about $12. So pretty comparable, I guess, to 2 shark bites. So it just depends on how you want to do it. With the shark bite, if you get clever and you can just cut out a limited amount, if it's a small break, then 1 shark bite can handle that. Okay, so I've pivoted them back in place. I've slid the pipe over, so we've got each pipe is at least back to the threads. And now all you would need to do is tighten these fittings with a wrench on each one. It doesn't have to be crazy tight, it just has to be crazy tight enough to not leak. So my encouragement is to not go just bonsai with the thing with the biggest wrenches you can. Get it tight to where you feel like it's comfortably tight. Go turn the water on, get some water flowing through that pipe and make sure it's not leaking. If it leaks a little bit, tighten it up. If it doesn't, leave it alone. Okay? The last way that I'm fond of for repairing leaks in a circumstance like this is to use what I call a solder sleeve. And basically what it is a section of copper that's slightly larger in diameter to standard copper pipe. It fits just over the top of it. And of course, I think it's too short. No, actually, it'll work now. The joy of this, let me show it in a way that makes more sense here. The joy of this sleeve is that you don't need a ton of material removed in order to make it work. If you can just get it moved enough out that you can slide it over it, then you can slide it back on. It works wonderfully. This can be cut in shorter sections so that you have shorter sleeves that'll fit over the top of it. They don't have any stops built into them that will resist movement. At this point, you would take it off, you would clean each pipe, you would clean the inside of the sleeve as best as you can. Apply flux on both of these, on all of the components, reassemble, solder, test for leaks. Have fun.